What's going on, guys? So in this video I want to talk about balancing your flywheels for the FDL3, and for you FPV guys, how this can translate into balancing your props. Let's go. When dealing with the FDL3, its main power source is actually drone motors. These are 2205. This particular one is a 2300 kV. And what's nice about these is I have a mess of them. I've also got a few of these guys. These are the old Frybot motors. These are what, 2206, 2450 kV. And you can also use these guys here. These are the 2206, 2350 kV. And these are also Lumineer. And if you look at the two of these here, you'll notice the tops are fairly familiar. And I'm sorry, I don't want to pull these out of the packaging. I don't know if I'm going to put these on a build or if I'm going to end up selling them. So just to keep them as new. But I've got this one out and I can show you this. So let's go with that. But anyway, the Lumineers are usually used more than the Emax. So the difference between the flywheels here is the Lumineers have this rounded keyed section right there, and that fits into the top of the bell, whereas the Emax, you can see, has got the it's just kind of elongated section where it just kind of clamps on two of these. There you go, you can kind of see it right there, and right there. The issue that I see here is these need to be offset. So if you look at this guy here, directly across from one another, we've got kind of a major support bar, and then we've got the indentation. So really, these are going to be much harder to balance. You almost need to offset this one just a little bit, and personally I would do them all the way around so that they hit each and every single one of them, and that would fix the balance issue that I can see with these. But anyway, yeah, let's get into just how to balance these, because there's special precautions that you want to take when printing these. And I'm going to show you the balancer that I've actually am still working on. I'm waiting on parts right now, but I can show you how that works too. So I'll get into that a little later in the video, and I'll also show you how to set up your slicer program to do all this. So ProjectFDL has, and I'll put the link for this below, they've got a really good write-up as to how to print these. And what I'm going to do is give you my opinions and just what I get from this, and just turn it into visual. So I'm going to use these as talking points. So I've gone ahead and started and finished some prints here. So these, when printing these, you put the flat side down. And I stopped these all at like layer 16. This one, for whatever reason, my machine didn't want to stop at layer 16. It just kept on printing. So that one's a little bit different. But I want to go into some of the stuff that they mention when printing these. And as you can see, I'm using different infill percentages and different infill styles for each of them. And I'm going to show you why I think they're bad or why I think they're good. So if we go into the talking points here, this first one, we've got the common nozzle sizes, 4 millimeters and 0.2 millimeter layer height. Most machines come with a 0.4 millimeter nozzle, and most slicer programs are very comfortable having your printer print at 0.2 millimeter layer heights. So that's not outside of anything that most of you are probably not already familiar with. And then they say 0.2 millimeter layer heights or lower, so you can go lower. That's fine, just don't go higher. And over here they state they go into what products they use. They've tried PETG, and they print mostly in PLA. And instead of reading that word for word, the PLA is a pretty good plastic for this. The reason being is because when these things spool up, just a little motor math here, we've got a 2450 kV motor, and what that is a measurement of how many RPMs per volt applied. So if we take our standard 3S battery charged fully, that's 4.2 volts per cell, times 3 cells, that's 12.6. So we take this 12.6 and we multiply it by the kV. So we go times 2450, and we get 30,000 RPMs. That's per each motor, is what these motors are going to spin at. This one's a little bit lower. I think this is a 24. No, this is a 2300. So this is going to spin a little bit slower. So as you can see, the importance of getting the balance of something like this right and printing it out of the proper material. So as I was saying earlier, they print these out of PLA. They started with PETG, and the problem with PETG is when spinning these things at 30,000 RPMs, if the PETG expands and breaks, it shatters. Whereas this stuff doesn't tend to do that. But the issue with PLA that you might run into is it has a tendency to warp with heat. Or if you were in, let's say, the summer and you left your blaster in the car, the flywheels can warp. So they also print these out of ABS, and I'm even thinking about trying to print these out of ASA. ASA is like ABS, it just doesn't come with some of the bad faults that ABS has. ABS is a little tough to print with. I'm not quite certain about ASA, how that is to print with, but I do know it doesn't have as much off-gassing issues. So I think I'm going to pick up a roll of that and play around with it. But this here is printed out of PLA. And like this stuff here, this is printed out of PETG, and I'm gonna get into why I have this stuff printed and on the desk here anyways. So when printing these, they go into, let's see, we covered why we're printing in PETG, or why we're not printing in PETG, and why we're printing in PLA. So the next thing here is we want to do 3 to 4 perimeters. Now if you're using Cura, the stock is 3 perimeters. I have bumped these up to 4, and that just gives you a stronger side to the material. Usually the top and the bottom is 4, so you're doing 4 on all corners, and it doesn't really add that much to print time at all. You probably won't even notice it. So the next thing I want to speak about is the infill, and that's why I have these printed here. So they call for, and I quote, infill should be roughly 20% rectilinear, rotated vertical and horizontal instead of the typical 45 degrees, and centered on the wheel. So what does that mean to me? So if you look here, rectilinear, you want something that comes straight out of the center of this, okay? So as you can see, the line right above my thumbs, that to me is rectilinear. But if I twist this, do we have, I mean, besides for this goober right here, we don't have a rectilinear line here. So this would be a failure according to their directions. Same here. This is not rectilinear, this is circular. Now these goober lines here, where the print head went over here, stopped, turned around, went over here, stopped, turned around, went over here, stopped, turned around. These are rectilinear, kind of, but as you can see, they're off. They're not straight. If I have a straight edge here, as you can see, I can put that there. They are definitely not straight. Okay, so that's going to throw off your balance. The other issue that I find with this, and this is called Coincentra, is the name of this infill, and these are all found in Cura. What this does is it prints these. They're a straight up and down line, and that's what the other thing they're calling for is linear, straight up and down. So as this prints, it starts to fold them over onto the one next to it. So this one folded to this one folded to this one. The issue that I'm seeing here, if you can hear that cracking, these are not very good. So what I see happening with this at 30,000 RPMs, I see the insides balling out, and they might do so at different, like this might come out more than this one. That's going to throw your balance off too. So this one is a failure. This one that I showed you earlier, this is called triangle hexagon. And the reason being is because you have a little triangle there and you have a little hexagon there. So this is also a failure. I'm going to skip over to this one. This is, if you're using Cura, this is the one that it always defaults to. And this is called cubic. And if you look, we don't have any of those rectilinear lines. The other issue here with this one is if you look at each of these lines, and let me see if I can get it right like that. Yeah, so if we're looking at these lines here that go from front to back, they're angled at a 45-degree angle or so. And then if we look at these lines, which are angled in this direction, you can see this one, this one, this one, this one. They're all angled this way at a 45-degree angle. And then finally, we have these ones that are going from the right to left of your screen. Those are angled towards us at a 45-degree angle. So we want to avoid any infill that does that. So as you can see, these kind of, they come out as a triangle and then they close back up as a triangle. And it's a really cool looking infill pattern, but we don't have that rectilinear that they are speaking of. There's no lines that come off this, and all of them are tilted rather than straight up and down. So this one is also a failure. Now I found these two, and I'm going to go into why I like one more than the other. I think they might still work, both. I'm going to go over this one, which to me is a maybe. So if you look at this, this is called lines. And what this is it's printed, it will print lines from bottom to top all the way across, and then it will stop and then print lines from left to right, right to left, back and forth this way. Then it will stop and go up and down. Then it will stop and go up and down. So you're getting those vertical lines that ProjectFDL speaks of. But if you don't have any good layer adhesion with these, there stands a chance that this stuff might expand. I mean, I feel like I can kind of move it with my finger. So to me, this may or may not pass. Who knows? But the issue that arises with this, and I'll show you in a moment, is this is going to make your flywheel a bit heavier because we're doing twice as much material. So again, this one's called lines. This one's a maybe. To me, this is the one that checks all the boxes. This one is called grid. It's got half the amount of printing here, and these are all printed at 20% infill. I don't know if I mentioned that earlier. As you can see, there's some goober that came out of my machine, and the reason being is because my machine, the nozzle is starting to clog, and some of this material I've opened a while ago, and I store it in a plastic bag with a Ziploc bag with a desiccant, but eventually this stuff kind of gains some water, and I think between the clogging and the moisture content in the filament, it's not printing as well as I had hoped. As you can see, you can almost see through the layer lines here, whereas if I print with something that's a bit newer and print on the that's the other thing, the machine that I printed these on, the print bed is starting to wear out, whereas these were printed on a brand new print bed, and as you can see, super flat. Same thing with these were printed on that same thing here, super flat. And this was, you know, high moisture content, and this printed out way better. But again, these were test pieces, and I'm gonna chuck them out after this video. So, but yeah, so disregard these lines here. That's not gonna happen in your print if you're using non-moisture content PLA or ASA. So anyway, the rectilinear, this one checks all the boxes. We've got a line out from the center there, a line out from the center there, a line out from the center there, and a line out from center there. So no matter which way we turn this, everything is equidistant. The other thing is this whole pattern is vertical. So that's the other thing that they ask for. So they use like a vertical or horizontal. This doesn't have really any horizontal. This is vertical. So I think this kind of checks the box. And if we look at their example, this is identical to what they're looking for, and this is their rectilinear, these red lines. So if you're printing in Cura, grid I think is the best way to go. So now if we go on to the next talking point here, they speak about layer seams. And what do we mean by layer seams? Well, when you're 3D printing, the nozzle head is going to go around. It's going to get back to the starting point and turn around and go back, and then turn around and then go back, and then turn around and go back. So what you're going to end up with is layer seams. And this seam is going to continue all the way down the edge. So if you can look right here, let me see if I can get that in focus. Okay, right there in the center of your screen, by my thumbnail there, you can see there's a layer seam, and that layer seam will continue throughout the entire print. The issue with that is that's going to throw off balance from this point to this point. So we want to avoid that. And how do we avoid that? We do what's called Z-seam hidden. And I'll show you how to do that in Cura later on in this video, and how to do all the settings for all of what I speak of in Cura in a little bit later in this video. So you want to avoid that. And when you do Z-seam random, you can kind of see here, there's all these little pock marks. This is printed with a Z-seam random, and what that does is it randomizes the location of where that decides to turn. So it'll go around, come around, stop, start over here, go around, come around, stop, start over here, come around, go around, stop. And what that will do is it will start you in the right direction to get these balanced. So instead of stopping over here and creating this lump on this side, it's all over the place. So some prints you might have too much over here, some you might have too much over here, what have you. But that's a good start to getting a nice and balanced flywheel. So moving on to the next talking point, we want roughly 10 grams per flywheel. So if I break out my scale here and I move this stuff to the side, and I think, yeah, you can see this. This is set to grams. So if I printed these, this is the Lumineer Flywheel. I printed these using this is called grid. So this is printed via grid, and this has the randomized Z seams. So if we go and weigh that, as you can see, that's 9 grams. And this one is printed identical to it. So if I weigh that one, we are also at 9 grams. So now, just for kicks, this is the Emax Flywheel. I printed this in the lines, and I printed 2 of them, both in the lines. These also have the randomized Z-seam. And if we notice how I was speaking about before, this is 10 grams. So the difference between lines and grids is going to add 1 gram to your flywheels. So I don't think it's a bad. I think if you wanted the heavier flywheels, then go for the lines. If you want the lighter flywheels, then go for the grid. All right, so the final talking point they go into is how to balance them. And they say use a prop balancer to balance these. And if you've been in the FPV hobby at all, or you're into model aircraft or something like that, prop balancing to me has kind of gone out of style in at least the mini quad realm. Props are done so well now, it's just slap them on and fly. So I looked on Thingiverse, and there really isn't a solution available that I kind of agree with. A lot of people are taking nails and just stuffing them through there and balancing with that. And a lot of people don't even have a way to balance the balancing stand. So I took and applied my knowledge of balancing motorcycle tires, and I looked at what was available and decided none of these are going to work out. So I went ahead and designed my own. I came up with this, and this was the first print. This is printed out of PLA on the CRS 10 Pro. So what I did here was just made the base, cut a few holes, and then brought up the sides, and then cut out this dip, and then put a few holes here. And how this works I had to adjust the holes a bit, but you take a couple of metal bars and you slide these through. These are stainless steel bars, and this is, instead of using a nail here, this is going to give you a nice smooth surface to work with. The other thing here, none of them included a bubble level, so I cut this out to supply it with a bubble level. And this is not quite done here. I've got the 4 holes in each corner. There's going to be a set of screws that go through the bottom. And then once those screws go through the bottom, I printed out some feet. And these feet are going to screw on to the bottom of those screws. So now you're going to be able to adjust this. When you put this on the table, you'll be able to adjust this. You can see the bubble level here. You'll be able to adjust this using the screws. Now you'll be able to adjust it from the top with an Allen key, or you can turn in and out the screws. So the object here is we want to take the, we want to get this base as level as possible utilizing that level. You can unscrew or screw in these TPU feet, or you can do it with an Allen wrench. Once this is sitting flush, we're going to go ahead and take, and I'm waiting, they're not quite in yet. I have more bars that are a little bit thinner. These bars here don't quite fit into the pulley. So the long and the short here is we're going to take the pulley and put the bar through here, and then we're going to just place it on here once this is level. So what you're going to do, and you wouldn't use a screwdriver, you would use another bar just like that, okay? So what you do is place this on here and just let it set. And if it starts rolling to one direction, what you want to do is get it to a point where it stops. And then just, you can kind of turn it and you'll see that it'll rock a little bit. What you want to do is let it settle to the heaviest point and then go ahead and mark it. And then what you can do is you can shave this, like shave the inside a little bit, and then come back and see. And just keep doing that until, no matter which way you place this on these bars, if it stays put, you have a completely balanced prop. If it starts to roll on its own, then you have an unbalanced prop. And then you're going to do that for both of them. And I'm saying prop, and this is flywheel, because this works for both props and flywheels. And this is just a smaller version of a motorcycle tire balancer. So that's all you're going to do. So if this sits, obviously it's not going to work because the weight of this is far too heavy, and the bars that I have are too big to go in there. So but I think you guys get the gist of how this works, and I can go into this a little bit better once I have it complete. But I just wanted to show you, I figured this is a prop balancing video. Let me at least show you how to prop balance and what I've got in the works. So I think what I'm going to do with this is put it on Thingiverse, and I think if there's any interest, I'll put together a few of them complete and mark them for sale. I don't know. They're not going to be cheap once these bars and the bubble levels, all this hardware adds up. Of course, you know, you go printing like 10 of these, it's going to be, you know, a quarter or half a spool of filament too. So, but yeah, so I mean, if you're interested, I will make these available. Just hit me up in the comment section below. Let me know. We can work something out. But anyway, yeah. Again, I'll if I put these up on Thingiverse, I'll put the links to all the materials that I'm using as well. So that's a quick look at how to balance your props. One other thing that I wanted to speak about before we end this video and head inside, and I could show you how to set up Cura, is the front nose section here. I went ahead and printed these out. So one special note, and I don't know if I did this in the 40 nose section here, but if we put this together, just two things I kind of noticed here. This is your motor mount here. So the motor side, you want there's kind of a flat side here, and then these line up with the little channel that goes through here. That's where your motor wires go. And then on the other side, where, let me use the motor for reference. So the motor's going to sit like this. you want to make sure that this kind of hogged out section here, that's where the prop nut side is going to go. Because what I've noticed with mine, and it may or may not be a big deal, I checked, it's in there right. So if we put this is going to sit like this. You got the flap spot towards this little hogged out section there. And if I take the other one and match it in similar direction there, so the motor will go to the flat side here. And yeah, so we want the flat side going towards the hogged out side. So there we go. So that's going to sit like this. So inside, and this is why I printed these out, if you look in there, we want to make sure that these are kind of lined up. The FDL that I built, they're a little off center, and they're off centered in a way that shims are not going to help. And the reason why I'm mentioning shims is because maybe yours are not lined up and you can use a shim. The shims are used for these guys because they're a shorter motor. At least the body style is. These, I think this is a 2205. Yeah, so the stator is a little bit smaller than the 2206s, but anyway, my point in doing in showing this is that these spacers exist in 2mm and 1.5mm. So I printed up a couple of these just to show you guys. Nice and quick print. If you need to move these away from the motor, or the motor away from its seat here, if you will. So as this sits here, if you need to move this away from the motor a little bit, you can do so. But again, mine is, I don't know, the reason why I printed these ones specifically is I'm gonna switch this out into my FDL and give them a try, because I might have 2205 flywheels in there and not the 2206. So just to give you a better idea, what mine looks like is it's offset like that. I really feel like they should be lined up like this. So I'm gonna end up switching mine in there, but I just wanted to make just kind of a note of that as something to look for as you're installing these into your FDL. So with that, I want to go ahead and show you how to set up Cura to print these and to get the proper infill and to find out where that Z-seam alignment is. So let's head inside. All right, so here we are in Cura, and I'll put a link to this in the description below if you don't have this already. You can use any slicer program. That's what this is. I happen to like this one, so this is what we're going to use. So what you want to do here is make sure you select your proper machine. If not, you can go to Add Printers or Manage Printers, and then you can go to Add. Over here, I have it set for PETG. That's the last thing I was printing. We're going to go to, for this, we are going to go to PLA or ABS. I'm just going to set this to PLA. And as you can see, our nozzle size is set to 0.4mm. That's what's in the machine, in the printer rather. Okay, so I'm going to refer to these talking points that we discussed earlier, just so we're on the same page. So as stated before, 0.4 is the nozzle size that they suggest, and printing at 0.2mm layer heights. So over here you can go to, that is standard quality 0.2, or you can go 0.16 or 0.12. Either or is fine, just nothing bigger. You don't want this 0.28 or anything higher than that. Moving right along, as suggested earlier, PLA or ABS is what they suggest. My thought is maybe maybe ASA. I don't know. So then they go into perimeters. Now, if we scroll up here, all right, here's our wall line count, and this may or may not be active in your settings. So if they're not, you can go into Configure Cura, go into Settings, and then you can type wall. So as you can see here, wall thickness is checked, and that puts it over here. So we're gonna get rid of that. So here we want to put this to 4. Wall line count. So the next thing we want to make sure is infill is at 20%. So infill density is 20%, or Cura tells us right here, that's infill 20%. So now we get into what type of infill we should use. And again, I had showed you grid. And if I go to preview and slice, grid is the one that I happen to like. So you can see here, we have all our rectilinear lines from the center, and everything is straight up and down as we look at this. Okay, so that's the one that I like. Now, the other thing is layer seams. So that is not selected by default. So I'm going to go back to prepare. We're going to go over here to preferences, configure Cura, settings, and then we're going to find it just by typing Z. And we can go Z seam alignment. So go ahead and check that if it's not already checked. And then we're going to scroll up here to shell. And it's going to be right here, Z seam alignment. User specified is the stock setting. We're going to go over here and click random. And as stated earlier, that's going to randomize the location where the nozzle starts each section of wall. And that's going to give you that zitted appearance, but it's going to give you a much more balanced flywheel. As we move along here, that's if you're printing in grid. Right here, that's going to give you the 9 gram. If you're printing out a PLA, that'll give you the 9 gram flywheel. Now, if we go over to lines, this one might be okay. I'm going to go ahead and slice this. This is going to give you the 10 gram if you're using the same PLA. I am using Hatchbox from Amazon. So if you're using that same PLA, it stands the chance to be the same PLA or the same weight. So if we zoom in here, as you can see, this particular lines goes right over left, left over right, all the way up. So if your printer is not adhering properly, this may cause some issue. So that is why I like the grid over the lines. But if you want the heavier flywheel, that might be the direction to go. And as you can see here with the grid, it's vertical. So that's just a quick look at how to set these up for printing on Cura. Once you're set here, you can save to file or print from SD once your SD card is in the slot, and then just bring this over to your printer, put this in, and go ahead and print. So that's a quick look at how to properly balance your flywheels and properly print them for the FDL3. Now, just a real quick word. According to Jesse from ProjectFDL, you do not need to balance these. But he's suggesting it because he says, if you have ever heard a fully balanced FDL, it sounds so good, and you will never not balance your flywheels. And to me, I think it's a safety issue too. If you accidentally printed out a PEGG and they're off balance, and that 30,000 RPMs, they start to expand a little bit and kapow. So yeah, just knowing what drone motors are capable of doing, I would definitely balance them, guys. It's not hard to do, and with this, it should be quick and easy. And there's that. For you FPV guys, you can use this. I printed this tall enough for a 5-inch, 6-inch prop. So if you are looking to, I think bullnose is the proper term. You want to cut off the tips of your props a little bit so you can get more oomph out of a prop, out of a smaller prop, or your prop just won't fit on your craft and you need to modify them. You can use this to balance your props and throw them on there and everything's good. So yeah, so there's that. So in moving forward, I do have a few more things to cover on the FDL. I still want to cover how to do motor direction And I want to show you guys it working too, because I am still waiting on SparkFun to swap me an actual working one so I can get that thing going. That's really the only thing keeping it from going. I also need magazines, and I got to get some foam darts too, so that's a thing that I need to remember to order in my busy schedule here. So anyway, as always, if you enjoyed this video, if you found it helpful, click that thumbs up button. It's down there somewhere. And if you haven't done it already, go ahead and punch that subscribe button, because you only get to do it once and it's fun. I'll catch you later. Peace.